So when we're multiplying two binomials, we use the full method first, outer, inner, last. This can be simplified because what is the square root of 4? 2. These can be combined because they are like radical expressions. So see if you can simplify that. Alright, so if I combine these together, and this is 2, and it's multiplied by 10, that'd be 20. And then I've got my constants here I can put together, so that would be 8 plus 14 square roots of 2. Not what you got? Alright, let's go back through it. This is 2, multiplied by that 10 is 20.
I didn't do any of that.
These are like radical. You got this part though?
I ended up with negative 12 plus 14 square root of 2 plus 10 square root of 2.
Alright, that's a good point. Once you take the square root of 4, you're finished with the square root symbol. You've already done the function, you know. It's like you wouldn't keep on taking absolute value. Once you're done, you're done. So the square root of 4 is 2, and 2 times that 10 is this 20,
Okay.
and then you put those together. Yes, ma'am.
Will the answer be written like that, like on an ACT or something?
It will. And yesterday, I think I said that the reason they put the radical symbol at the end is because somebody might do, like, and you're like, is that 8 under there? You know, they write it real messy. I know y'all don't know anybody that writes messy, but, you know, that might happen. So that's why they usually do the radical last. And you're going to find the same is true when we talk about complex numbers. When they use the i's in the number, I represents the square root of -1. We'll try to get into that today. But they'll write the I last, too, just like they use a radical. What are you shaking your head for? Daniel?
How'd you get the 10 square root?
How do you get the 10 square root of 4? 5 times 2 is 10. And square root of 2 times square root of 2 is square root of 4. That's that product rule. If they had the same index number, they're both square root. I multiply the radicands and got my 4. Let's try it again. Let's do this one. Alright, so first would be 8 square roots of what? I'm multiplying, not adding and subtracting. So I can multiply anything.
Is that negative 3 right there? Is that negative?
Oh, is it a negative? I thought it was 4 square roots of 3. I think he's right. Let me back up. I think this is 4 minus the square root of 3 and 2 square roots of 3 plus 5. Thank you for saying that. Alright, so first would be 4 times 2 would be 8 square roots of 3. Outer, of course, is 20. Inner would be -2 square roots of what?
6.
Multiply
9.
Yes. And then last would be, got different signs, -5 square roots of 3. Alright, copy it and let's look back over it.
Where'd your negative go on the first one?
Where did it go?
Yeah, it was.
When I multiplied 2 times negative square root of 3, I got negative, where am
I was talking about the first, like,
I?
When you
Out. Maybe
multiply
I'm
them.
getting lost here. 8, 20, -2 square roots of 9, okay, and then -5 square roots of 3.
Okay.
It was just part of, it's the sign of this term.
oh.
Makes sense? We're good?
We'll
Alright, let's
get-
try it again.
we'll get the next
First,
one.
4 times 2, or 4 times 2 square root of 3 would be 4 times 2 is 8, and then there's my square root of 3. Outer, that's just numbers, 4 times 5. Inner, -2 square roots of 3 times the square root of 3, and we've got different signs, so it's -2, and then 3 times 3 is 9. And then last, 5 times the square root of -3 is -5 square root of 3. Now, these are like terms. This can be simplified because what's the square root of 9? 3. So we gotta do all that. Alright, so 8 of them, like radical expressions, 8 of them minus 5 of them gives me 3 of them. Notice when you add and subtract, you don't change the number under the radical symbol, but when you multiply, you do. That's important to know. When you add and subtract, you're not going to change the number under the radical symbol. You're just combining like terms. But when you multiply, as long as the index numbers, which are like square root, cube root, whatever, as long as they're the same, you do multiply the radicand. Alright? And so what is the square root of 9? 3. 3 times negative 2 would be negative 6. So this is a negative 6. And 20 and a negative 6 make 14. But like she was saying earlier, they're going to write it this way with the radical at the end.
Agreed.
And we can't divide by 0. That's just a mathematical rule. It's undefined. There's no number exists that if I divide something by 0, that I get an answer. It is also true that you would not leave a fraction that's not reduced. Like you wouldn't leave 4/8. You would reduce that to 1/2. Why do you do that? Because your teacher told you to, right? It's not in simplest form. Is why. It's not. You wouldn't leave it. It's not in simplest form. All right. Thinking of all the things we can't do. Also, we cannot leave a radical symbol in the denominator. A square root of something, a cube root of something, you cannot leave that in the denominator. It's not simplest form. It's not being simplified or put in the best terms, okay? All right, so what we'll do here is we have to think, all right, gosh, what would I multiply by the square root of 3 to give me a perfect square in the denominator so that I won't have a radical symbol anymore? Well, anytime you want a perfect square, you just multiply something by itself.
Heard that.
Okay? Now, what I do to the denominator, I also do to the numerator. Because really, what have I multiplied by here?
1.
Yeah. That's really just a sneaky way of writing 1. What I do to the denominator, I do to the numerator, and really I've just written 1 in a really weird way here. And what happens when you multiply something by 1? Do you change its value?
No.
In the identity property? No. Alright, so 1 times the square root of 3 is the square root of 3. And the square root of 3 times the square root of 3 is
Square root of 3.
square root of 9, which is what? 3. Alright, let me say what I said earlier again for you to hear. If you're adding and subtracting, you don't change the number under the radical symbol, but when you're multiplying, you do. Okay, so the square root of 3 times the square root of 3 is the square root of 9. I did that on purpose to make a perfect square so that I could take the square root and wouldn't have a radical in the denominator.
Is this not a radical or radicand?
Alright, let's take a time out here. Let's look at this one. Before I go on over here, let's look at this one. If I wanted to rationalize the denominator, that's the formal term for what we're doing. We're simplifying this. We're putting it in the best form, okay? But it's called rationalizing the denominator. What would I multiply here by top and bottom, by numerator and denominator? What would make this a perfect square? Multiplying it by itself, yeah. And what I do to the denominator, I must also do to the numerator. What's my final answer?
2 square root of 3 over 9.
Over the square root of 9, which is 3.
Sure. Almost got it.
Good deal? Let's look at this problem. How is this problem different from my first problem? What have I got on the bottom?
Addition.
Yes. Yeah. Instead of a monomial, I have a binomial. Okay. Now here's the trick to that. If I want to, let's the right word? If I want to fix a binomial, the right word is rationalize. If I want to rationalize the denominator that has a binomial, the way to get rid of the radical symbol is to multiply that binomial by its conjugate. What does that mean?
I don't know.
Conjugates, think back to ninth grade factoring, the difference of two squares. You have your conjugates like x plus 2 and x minus 2. Conjugates look exactly the same except for their what? Signs in the middle. So if this is 1 plus the square root of 3, its conjugate is 1 minus the square root of 3. So you want to write yourself a note here to use the conjugate. When it was just one term, just a monomial, I just multiplied by itself. Okay, now here's another thing we gotta remember. We're multiplying binomials. We're multiplying binomials. What method do you use when you multiply binomials? FOIL, that's right, F-O-I-L. Alright, so the numerator, I'm going to have 2 times 1 and 2 times negative square root of 3. The denominator, here's my binomials. Binomial times binomial. So we'll do first, outer, inner, last. What does last give me? Negative square root of 9. Exactly. What's going to happen right here?
Cancel out.
Negative square root of 3, positive square root of 3. That's it. That's why we use the conjugate. Is because that will always, you don't hear that much in math, do you? That will always make the radicals cancel when you use the conjugate. Now what is the square root of 9? 3. So my numerator is 2 minus 2 squared to 3. What's my denominator? 1 minus 3. Negative 2. When I use that conjugate, I did it on purpose so that these radicals would cancel out. This one's going to be a perfect square, and I got what we were aiming for. There's no radical in the denominator. Now, I need to say this. When this number, and this number are reducible by a common factor, then I reduce them. Notice the number I did not circle. I did not circle that, did I? Okay. So since all these are reducible by 2, my answer would be over a negative 1. Do you ever just leave 1 as a denominator? We don't usually do that, do we? So what am I going to do with this negative? I'm going to bring it, I'm going to bring it to the top. I'm not going to flip it. But I'm going to take that negative up here to the top because I'm dividing by, when you divide something by negative 1, what happens to the signs? Don't they change? Yeah. And so that would be negative 1 plus 1 square root to 3. And you can write that 1 right there, or not. The book's not. Alright, we've added, subtracted, multiplied, and divided, even though I know y'all wanted them one at a time. But now we're going to practice them. Okay? Now, what is true? This is supposed to be an equal sign, I think. What is true about adding and subtracting radicals? Can I add and subtract anything?
No.
They have to be what? Like terms. Like radical expressions. Okay. Do 27, 75, and 18 contain perfect square factors so that I can simplify them?
3.
Like what's a perfect square that goes into 27?
9.
Remember what I told you yesterday? What's probably gonna go into these two? Probably. At least one of them here. How does 75 break up?
25 times 3.
Now 3 will go into 18 true, but it'll go 6 times and neither one of them are a perfect square. So what is a perfect square that'll go into 18?
9 times 2.
Alright, so these are gonna be like radical expressions, this one's not. Alright, what is the square root of 9?
3.
So I've got this 2 out here, I'm showing all my work, okay? This 3 comes out, the square root of 9 comes out, and this 3 is left underneath. The square root of 25 comes out, it's 5, and that 3 stays here. The square root of 9 is 3, and that 2 stays underneath. 2 times 3 would be 6 square roots of 3. 3 times 5 is 15 square roots of 3. And here's my negative 3 square roots of 2. That's just kind of a tag along. It's not a like term to these. These are like terms. I'm going to repeat myself. I've already said this 2 or 3 times. But when you're adding and subtracting, you do not change the number under the radical. You do not change the radicand. When you're multiplying and dividing, you do. When you're adding and subtracting, you don't. So what is 6 square roots of 3 plus 15 square roots of 3? 21 square roots of 3. And then I got a minus 3 square roots of 2 on here. Y'all see that?
Yeah.
Any questions? Getting better? What's that little formula I've told you to remember? That's the most important thing we've talked about.
Power over root.
Power over root. Power over root. So this would be A to what power? Let me write that bigger. Maybe you just can't see. You're sitting in the back. Probably can't. So that will be A to the power divided by root. What? 1/3. And B to the 1/2. And that would be right here, right? Okay. Can you simplify that one? Power over root. Power over root. That is the cube root of A squared right now. So the answer would be what? A to the 2/3. Alright, this one is the cube root of 8x to the 6th. What is the cube root of 8? What times itself 3 times gives you 8. And if I did power over root, that would be x squared. Agree? Power over root.